Hello, my dear students and the rest of the learners. Welcome to part 16 in a 95-part series of tutorials in object-oriented programming in C++. In this tutorial, I'm going to look at language structure, or what we call the format of a C++ program. My name is MJM, or you can simply call me Emily Swap. The topic in this set of tutorials, or in the following set of tutorials, that is tutorial number 16, 17, and 18, amongst others, is language structures of object-oriented programming. And in this tutorial, my focus will be on language structure of a C++ program. Or the subtopic is language structure of a C++ program. The following is a simple example of a C++ program that indicates the general structure or format of a C++ program. The explanations of what each line in the following code or a program represents or means is after this code. Always remember that. Number one, every statement in C++ ends with a semicolon, which is used to mark the end of the statement, and in fact, it must be included at the end of all expression statements. Secondly, the code is normally in lowercase because C++ is case sensitive, and thus the entire source code should be written or coded in lowercase, that is, in small letters. So normally, whenever you are writing a C++ program, the following is supposed to be its format. In as much as this basic code or basic structure can be advanced and improved as you move towards making the C++ program to be object-oriented. And therefore, my first statement in this illustration is / my first program in C++. Whenever you wanted to add a comment within your program, this is how it's supposed to look like. My second statement here reads as #include angled bracket iostream.h, and then we have the other angled bracket. So ordinarily, the first symbol in this statement, which you read as #include, is called a pound sign, while iostream.h is included in a pair of angled brackets, as you can see. The third statement or line is using namespace std, semicolon. Std stands for standard. So using namespace standard. I will explain about what that means in this tutorial. Then my fourth line is also a comment. And the comment is that in object-oriented programs, you usually define classes at this point. That is before main. My next line is int main, followed by a pair of parentheses. So these symbols after main are called parentheses. So int, main, and a pair of parentheses. And then we have what we call the left brace. The left brace, or you can call it opening brace. And then I have my next line as int, miaka, and semicolon. Int, miaka, semicolon. My next instruction reads, see out, not count. It is read as see out, and then followed by what we call the output operators. Output operator, or what you can call as the insertion operator. Then I have the statement or the ones, karibu na ujihisi nyumbani, \n. \n is called an escape sequence character. So that statement, I have enclosed it in double quotes. And then semicolon. I repeat, see out, insertion operator, opening, double quotes, karibu na ujihisi nyumbani, \n, closing, double quotes, semicolon. See out, followed by output or insertion operator. Then karibu na ujihisi nyumbani, \n, and \n is called an escape sequence character. Then semicolon. Then see out, insertion operator. Then a string of characters, or a string which reads una miaka mingapi. Then insertion operator, end line, semicolon. See in, extraction operator, miaka, semicolon. See in, extraction operator, miaka, semicolon. See out, insertion operator, followed by a string or a sequence of characters enclosed in double quotes. And this reads, welcome to C++ programming. You are insertion operator, miaka, insertion operator, years old, escape sequence character, semicolon. Then return 0, semicolon, and we have the closing brace, or call it the right brace. Now, we are going to discuss, or I will explain each of the lines as follows. Line 1 will be this statement. Then we have our second line. Then our third line. Then our fourth line. Fifth line. Sixth line. Seventh line. Eighth line. Ninth line. 10th line. 11th line. 12th line. And 13th line. So what does each of these lines mean? And what do they represent? So let's begin with our first line. So this is a comment line. It is a comment line. There are two types of comments in C++, which are the line comment and the block comment. The line comment is usually coded as follows. So you have a pair of forward slash signs or symbols. Then you write your comment. So this comment is used when you want to have a single line of comments. A single comment occupying only a single line. So we use a pair of forward slashes followed by your comment, which should occupy only a single line. For example, my first program in C++. So that's how you write a single line comment. The line comment discards the code from the pair of slashes until the end of the same line. It is thus applied on a single line of code, just as I have said. While the block comment is usually coded as follows. So you have the forward slash followed by asterisk, block comment, asterisk, and then forward slash. So the block comment, what I have written in blue, you replace it with your own comment. So we use this pair of comments or symbols when you want to have a comment that spans across more than one line, like a paragraph. So how do we write it? You have the forward slash asterisk. Then you write your comment, which can occupy more than one line. And then to indicate that that is the end of the comment, you have the asterisk followed by a forward slash. For example, forward slash asterisk. My first C++ program, asterisk, forward slash. So the block comment starts at the first forward slash asterisk characters and ends with the next asterisk forward slash characters are reached. It's usually applied to include several lines, though it can also be applied on a single line, like in my program. You can thus replace the statement, my first program in C++, with your own ones and in any language. This is because whatever that follows, the symbols for comments or whatever that is enclosed in the pair of symbols for comments is not executed by the compiler, nor is it known or even read by the compiler. It's just known by the programmer. So whenever you want to have comments within your program, if it is going to occupy a single line, you use a pair of forward slashes. If you want it to occupy more than one line, you use the block comment symbols or signs, which are forward slash followed by its asterisk. And then once you are through with writing your comment, you then write asterisk and forward slash to mark the end of the comment. So a comment is simply a brief description of what the program or a section of source code does. Comments in a program makes the program more readable and easier to be understood, even by the programmers who were not involved in the initial coding process. It also makes debugging easy because a programmer is able to easily identify the section of code that performs a certain task and debug it. My second line is this one, which reads, or which you can read as hash include angled bracket iostream.h angled bracket. This is usually a directive for the preprocessor. Preprocessor directives are commands that you supply to the processor. So if at any time you want to include, for example, a file in your source code, then you need to include it using hash include or pound symbol include. Then we have the angled bracket outstream.h and angled bracket. These that I'm calling angled brackets, you can call them the less than symbol and the greater than symbol. So preprocessor directives are commands that will supply to the processor. All preprocessor directives begin with a pound sign. They all begin with a pound sign. They are not executable code lines, but indications for the compiler. C++ routes your programs through a preprocessor before it compiles them. The preprocessor can be called a precompiler because it preprocesses and prepares your source code for compiling before your compiler receives them. It tells the compiler to include the outstream library, which is the basic standard input-output library in C++. The outstream header file gives your C++ compiler the needed information about the cin and cout inbuilt operators, as well as other useful built-in routines that perform input and output. The outstream.h stands for input stroke output stream header. I for input, O for output, then stream dot H. H meaning handler. It contains the declarations of the basic standard input-output library that has definitions for C-in and C-out objects. So if within your program, you know that you are going to be making use of input devices like a keyboard, and you are going to be making use of output devices like monitor, those are defined, or the compiler is meant to know about them from the outstream header file. Because outstream header file contains the definitions for C-in and C-out objects. And for that reason, you have to include outstream header file within your source code. Otherwise, the C-in and the C-out objects will not be known, and therefore you are going to get errors in your program. Therefore, if you be requiring the users to key in data through the keyboard and have output displayed on the screen, that is, if you want to make use of input and output devices, just as I have said, you have to include the outstream preprocessor directive in your source code. So the angled brackets tell the preprocessor first to look for the include file in the directory where the source code is stored, and then look for it in the system's include directory. The hash include is thus used to include special system files called header files, indicated with .h extension. For example, outstream.h for helping C++ interpret the many inbuilt functions that a programmer uses. The preprocessor directives cause your C++ preprocessor to change your source code, but these changes last only as long as the compilation. All header files that you may need to use in your program should be placed before main in every program that you write. That is before main function in every program that you write. Line 3 is using namespace std semicolon. What does that mean? It is used for declaring all the elements of the standard C++ library with the name std. What does std stand for? It stands for standard. So, in order to access its functionality, we declare with this expression that we will be using these entities. So you write using namespace standard semicolon. In my subsequent presentations or tutorials, I am going to discuss further namespace. This statement using namespace std semicolon is thus used in programs that make use of the standard library. Line 4 is a comment statement that is informing us about the position where the classes are defined within an OOP code. So it is just a comment statement that I have used in my source code to inform you that you always define the classes, or usually define the classes before the main function. A class is a template that specifies the data and behavior of an object and is a static description of a set of objects. In my subsequent presentations in this series, we are going to see how we make use of classes And I will also explain classes further in the same way that I also explained them in the previous tutorials in this series. So if you want to know more about classes, kindly go through the previous tutorials in this series in object-oriented programming because I have explained about classes in depth. The classes are declared using the keyword class. The functions are included as members of the class. This is slide 5, which reads int main, and then followed by a pair of parentheses. So what does each part in this statement mean? So int main followed by the pair of parentheses is a line which indicates the beginning of the definition of the main function. It is therefore a line which defines the main function. The word main is always followed by a pair of parentheses because it is a function declaration. So every program that you write in C++, every program that you write in C++ has a main function because the main is the one which controls how the rest of the code will be executed. The arrangement of set of statements or lines or instructions within the main indicates the order in which the compiler will follow during compilation, and is the same order which is followed during execution of the program. So the main function is the point where all C++ programs start their execution. All the instructions contained within this function's definition will always be the first ones to be executed in any C++ program. This function may or may not have arguments that can appear after the function name, but between the pair of parentheses. In other words, my dear students and the rest of the learners, I am saying that if your program or if the main function is going to be sending or receiving any parameters from anywhere, or what we call arguments, you can always include them here. You always include them in between the parentheses. But in my program that we are using, or that I'm using to demonstrate how to write a C++ program, I don't have any arguments. Nor do I have any parameters. But if we had them, we could include them within the pair of parentheses. The word int appearing before main indicates that the main function is expected to return a value which is a whole number or integer. If the main function is not expected to return any value, the word int can be replaced by void. For example, void main followed by the pair of parentheses, indicating that the main is a function. And of course, it is the main function. So if the main function is not expected to return any value, you can replace the word int with void. Therefore, all C++ programs have one main function. Before I go to line 6, let me still explain or mention something that instead of having int for integer, meaning the function main is going or expected to return a whole number or an integer. If it's going to return another type of data that I'm going to discuss later under data types, then we have, or we can have that data type, the return type, where the int or where the void is. And we are going to learn more about the data types that even functions can return later in 18th tutorial. The next line is line 6, which has this symbol. This symbol or this character is called the left or opening brace. It marks the beginning of the body of every function, and thus, in this case, it marks the beginning for the main function's body. That is, the point at which the compiler starts executing whatever instructions that follows it. Line 7 is int miaka, semicolon. This is a variable declaration statement. So it is a declaration statement for a variable called miaka. It indicates the type of data that will be stored in a memory location called miaka. Therefore, miaka is a name of a memory location that is expected to hold value or data of type integer. In this case, the type of data to be stored in the memory location called miaka will be of type integer, meaning a whole number. What this means, my dear students and the rest of the learners, is that what the compiler is usually interested with and what it knows is not the name that you give to your memory location or to your variable. What it needs to know is the data type or the type of data that is going to be held in a certain memory location so that it is able to set aside adequate memory to hold that value. And therefore, miaka can be in any language. In other words, a variable name can be in any language, but the data type must be the type that is known or that you define before you use. It can therefore be replaced with other data types that I'm going to discuss in my subsequent presentations. A variable is a symbolic name for a memory location in which data can be stored and subsequently recorded. It holds data values so that they can be utilized in various computations in a program. Therefore, you must declare variables in your program if you need to hold any data for use in performing processing tasks during program execution. Line 8 is or is cout. Cout, insertion operator. Karibu na ujihisi nyumbani. Escape sequence character N, then semicolon. Whenever you have a statement that would like to be displayed on the screen, and it is not stored in any memory location, you should always write it as a string. That is a sequence of characters that you enclose using the opening double quotes and the closing double quotes. So whenever you have a set of statements or ones that you like to be displayed on the screen that the user can be able to interact with, then you always enclose them in double quotes, as you can see in this statement. So my set of characters, my string, is not known by the compiler. Once I have put them in double quotes, like the way I have done, it simply means that that is a string of characters, or it's a string, a set or a sequence of characters that are going to be displayed on the screen just as they are. So this statement displays a string, karibu na ujihisi nyumbani, on the screen. And then the cursor is moved to a new line just below where this statement will be displayed. So the work of the \n, or the escape sequence character, which we write as \n, remember, we treat it, or it is treated by the compiler as a single character, and it is called escape sequence character n. So the name of this sequence, escape sequence character, is new line. New line escape sequence character. It is called a new line character. So when this statement here is going to be executed, what will be done, or what our processor will do, it will display the statement, karibu na ujihisi nyumbani, and then the cursor will be blinking below it. Why? Because the new line character, once executed, will print a new blank line immediately below where the statement, karibu na ujihisi nyumbani, will be displayed on the screen. A string is any sequence of characters enclosed in double quotes. The symbol less than, a pair of less than symbols, less than in mathematics. You know, this symbol is usually a less than sign. So a double, or a pair of less than symbols or less than operators, when they are put together this way in C++, we don't call them less than signs. When they appear the way they are, we call them an output operator. It is treated as a single operator. And therefore, it is called an output operator, or an insertion operator. So the symbol, this one, the one which I'm displaying on the screen, the symbol, this symbol is an output operator which takes an output stream as its left operand and an expression as its right operand, and it causes the value of the latter to be sent to the former. So, my dear students and the rest of the learners, kindly note that this symbol is called an output operator or an extraction operator. And what does it do? What it does is that it takes an output stream as its left operand and an expression as its right operand, and it causes the value of the latter to be sent to the former. It can thus be also called an insertion operator. A stream is an object which performs input and output. Therefore, Cout is the standard output stream in C++. An output stream is something that takes character data and gets them an output device. An operator is something that performs an action on one or more objects, while an operand is an object or data that is acted upon by an operator to generate a given or required result. So the statement C out followed by insertion operator tells the system to send the message following it to the C out object, which is usually the standard output stream, which usually represents the computer display, screen, or monitor. That is, the C out is an operator that sends data to the standard output device, which is usually the screen. The name C out stands for console output, and the console represents the screen. So C for console, out for output, C out, C out. And that represents the screen or a monitor. Therefore, C out is the name of the standard output stream in C++, and the meaning of the entire statement is to insert the sequence of characters enclosed in double quotes or string into the standard output stream, which is the screen. In other words, this is a statement that is used to display a sequence of characters enclosed in double quotes on the screen, such as the computer monitor. Cout is thus an operator that has been described to the compiler in the hash include file called outstream.h, and it sends the output to the screen. I repeat, cout is an operator that has been described to the compiler in the hash include file called iostream, and it sends the output to the screen. The end of this statement is usually marked with a semicolon. Remember, I have said at the beginning of this tutorial that every instruction or every statement in C++ is terminated with a semicolon, except preprocessor directives and the function header where the definition has been included. Line 9 reads cout insertion operator una miaka ngapi? Insertion operator end line semicolon. What does each of these parts do? So this line is similar to line 7. The only added information here is ENDL, which just serves like the new line operator. So when ENDL is encountered by the compiler or processor, it simply indicates the end of line and the start of a new line. So end line serves as a new line operator. That is the escape sequence character \n, which we are calling the new line operator. So end line positions the screen cursor to the beginning of the next line. So you can either use the escape sequence character or you use the end line character or end line word within your program. Both of them do the same thing. The new line operator, which you write as \n, or the ENDL or end line. This statement reads as follows. Get the sequence of characters una miaka mingapi and output them through an output device such as the screen. And that's the work of C out. So pick the sequence of characters, una miaka mingapi, and display them on the screen, on the console, output console, the screen. So display una miaka mingapi on the screen, and then move the cursor to the next new line. Line 10 reads C in extraction operator, miaka, semicolon. This statement is used to read the value entered by the user into the memory. C in, pronounced as C in, stands for console input. Console input, C in. That is an input device such as the keyboard. So the extraction operator operates as the extraction operator for reading variables. Or in other words, let me rephrase my statement. I am saying that this pair of greater than sign symbol, in mathematics, this is greater than sign. So a pair of greater than signs, two of them, we don't call them greater than signs or symbols in C++. When you write them this way, this is treated as a single operator. And therefore, the name of this operator is extraction operator. Or sometimes you can call it the input operator, the extraction operator, or you can call it the input operator. So it is not greater than sign. You don't call it greater than sign in C++. It is thus called an extraction operator. So the above statement, or this statement here, this statement means this statement here means this statement means read the value entered by the user through an input device and store it in a memory location called miaka. Therefore, C-in operator is one way to input data from the keyboard. When the program reaches the line with the C-in operator, it gives the user an opportunity to enter values directly into variables using the keyboard. So you just type. The information about C-in is found in our stream header file. Therefore, the definition of C-in is found in the header file called our stream that I have already said that you need to include within your program if you are going to be making use of any input device or output device like keyboard for entry of data using C-in or monitor for output of data using C-out. So include it in your program if you know that you will use C-in. Our 11th line is C-out, followed by insertion operator, then the string, welcome to C++ programming, you are. Then insertion operator, miaka. Insertion operator, ES-code, followed by escape sequence character for the new line and a semicolon. What this statement means is write out, C-out, write out the sequence of characters enclosed in double quotes That is, write out welcome to C++ programming, you are inclusive of the value from the main memory or from the memory location called Miaka. So write out welcome to C++ programming, you are pick what is stored in the memory location called Miaka and write it out here. So write out welcome to C++ programming. You are pick what is the memory location called Miaka. Then write out years old. So this statement means write out the sequence of characters and closed interval codes inclusive of the value from the memory location called Miaka to the computer screen and write out a new blank line just below the displayed statement. If, for example, the value stored in the memory location called Miaka is 21, if when the user was prompted to key in his or her age, this user typed in the value 21 and pressed enter, that value was picked just as I've explained and stored in a memory location called Miaka. So the cout statement will pick 21 from the memory location called Miaka and display it at the right position within the statement. So the following will be the statement that will be displayed on the screen with the cursor blinking just below it. Welcome to C++ programming. You are 21 years old. So that is the statement which will appear on the screen because cout simply says, write out the following sequence of characters on the screen, but remember to pick the value held in memory location called Miaka and have it or display it in between R and years. Therefore, line 10 is similar to line 7 and 8. It just displays the message and the value of variable Miaka on the screen. It indicates how to cascade the insertion operator. Line 12 is return 0, semicolon. This statement is used to terminate the execution of the program and returns control to the computer's operating system. The number 0 is used to signal that the program has ended successfully. So the return command simply tells the C++ program or compiler that the function is finished, the main function is finished, and thus the C++ returns control to whatever was controlling the program before it started running. Control can also be returned to either DOS or C++ editing environment. Actually, many return statements are optional, but C++ can know when it has reached the end of the program without the return statement. For example, if the main function is not expected to return any value, meaning that it had been coded as void main instead of int main, then in this case, we shall not include the return statement in our code. However, it is a good programming practice to always have a return statement at the end of every function, including main function, so that you don't forget to include it in functions that return values to the coding function. In addition, you can include parentheses around a return value, especially when you want to return an expression. For example, you can have our return statement coded as return 0 and closed in a pair of parentheses and semicolon. Line 13, this line 13 has only a single symbol. This is a closing symbol. We call it a closing brace or simply a right brace. The closing brace after the return does two things in a program. Number one, it signals the end of a block that has been begun earlier with an opening brace, and it signals also the end of a program. So whenever you have a function that has an opening brace, whenever you have the left brace, you must have its pair. It must always be a pair of opening brace and closing brace, or left brace and right brace. So if, for example, you have a function like main, where you commenced with having the left brace, when you are through with your set of instructions or statements within that function, you should always have the closing, or what we are calling the right brace, to indicate the end of the block. And also, we usually use it to indicate the end of a program. We usually use it to indicate the end of a program. So, my dear students and the rest of the learners, let's have a recap before we end this tutorial. Let's have a recap. So what have we said? What we have said is, if you go back to our initial program, this is what we have said. So here is our recap. So this, I have said this is normally how the format of a simple C++ program would look like. So what have we said? What we have said is this, that whenever you are writing your program, it's always good to include comments within it. The comments make the program readable and also easy to understand. The comments indicate what a program is doing or a section of a program is doing. So even the names of the programs, if you want to save your program or your source code with a certain name, it's always going to include it as a comment within your program. And I have said there are two ways of inserting comments within your code. One way is to use this symbol. So this symbol means that you have a comment occupying only a single line, like my first program in C++. So that's how you tell the compiler that this is a comment. So once the compiler encounters this symbol, it does not read what is here, so it skips what is there. Then I have said that this other statement is what we call a preprocessor directive. And preprocessor directives always are indicated with a pound sign, then include, and then the header file that contains the definitions of functions that you are going to be using within your program. For example, IOStream is a header file, is a file that has definitions for input function and output functions. And what do these functions do? They have the definition of, for input, they have the definition for CIN, console input, and output, that is console out. So if you're going to make use of CIN and Cout, you're going to make use of an input device, an input and output device, like the monitor, you should always remember that the definitions for the input CIN function or monitor function, the Cout, are in the header file, called outstream. So you should revoke it. You should inform the compiler that those definitions are within that file called outstream. So included within our program. So hash include outstream.h. And the header files can be of many or can be many, like outstream.h and others that I'm going to learn or come across in my subsequent series of presentations. And then we have the standard. We have using namespace. And remember what we have said, that whenever you're going to be using standard input and output devices, it's always good to include this statement within your program. And then this is a comment statement. Then every program in C, every program in C++, not in C, but every program in C++ as a main function. And the purpose of the main function is to control how the program will flow, or how statements, the rest of the statements will be executed. And therefore, you must always have this function included within your code. And the name of that function is main. It's always called main. And of course, it's the main function. And this thing is the return type. So if the function main is supposed to return a value, like to the processor, or return it to the editor, or turn it to this operating system on us, then you should always include the return type. So why do we have return type? Is because every function, a function is expected to return a certain value. But if it's not going to return a certain value, if, for example, it's a procedure, which of course we don't call it a procedure within C++, but it's also a function. So if a function is not going to return a value, use this as it, just use the one involved. So, but normally we rate it as int main because of this return value. So you have int here because the program of the function is going to return the value which is a whole number. In our case, it is an integer 0. So you have int here. If you have void here, then the return statement here may not be included. You can avoid it. You can do away with it because it's nothing you are returning. So functions that do not return any value to the caller do not have return. But any function that's supposed to perform some activities and then is expected to return value to the caller, then it has a return statement. So int main is written that way. We follow by a pair of parameters. So this symbol here, or these types of brackets here, we don't call them brackets. And then whenever you have a function like this main, just below it, you should always have the brace. You should always have this left brace to indicate the starting point of execution of instructions within that function. And within here, I am setting memory location aside to hold a whole number, the type of integer, that variable, that is nyata. So you always need to clear your variables that will be using. Set memory locations aside that can hold certain values if your program is expected to store or hold some values. And then see out. This statement is displayed on the screen because see out stands for console out, console output, console output. Pick whatever is here, whatever that is following this insertion operator. Pick it and write it out on the screen. And once you read the statement, move to the next new line, leave a new line. The same is being done by this statement. Pick una miaka mingapi. Write it or display it on an output device, which in this case is the monitor. So write this statement on the monitor. Once you are through with writing, print a new line. Do it. And then this is a prompt statement. It prompts the user to enter the value for age. Una miaka mingapi? Kumi. So the person will type 10. When the 10 is typed and the user presses enter key, that value 10 will be stored in the memory location that we set aside, and we called it miaka. So the value entered by the user here, if, for example, the user types 10, that 10 will be picked and it will be stored in a memory location called miaka. So this statement I've said, it simply means pick the value or read the value that has been typed by the user. Get that value that has been typed through an input device, that has been typed through and or that has been entered using an input device. Pick that value that has been entered using an input device and store it in the memory location set aside called miaka. So this variable name here should be the same as this one here. Otherwise, the value entered will not be stored anywhere. There will be no place to store it. Once you agree with that, write out. Pick this set of statements. Write them on an output device on the screen. See out, console output, console out. So write this statement on the screen. Welcome to C++ programming. You are, pick what is in the memory location called miaka and display it here. So you are, welcome to C++ programming. You are 10 years old, and write or print a new line. Then return 0. Once the compiler encounters this statement, it tells it that the processing of the instructions within the main function is complete. So return control the processor and end or terminate the program. So my dear students and the rest of the learners, that's what my basic program, this program that I have explained means. So whenever you are writing any program, it's always important that you abide with this format for writing a C++ program. And as we proceed with object-oriented programming, I'll show you how we are going to bring further changes or inclusions, further inclusions into this structure. But the structure or the format remains. So with that, my dear students and the rest of the learners, we have come to the end of part 16 of the series. You can continue to part 17 of 95, where I am going to explain or outline some features of object-oriented programming languages and also mention something on file extensions. Congratulations for learning part 16 of 95 on language structure of a C++ program. You can access videos for the other parts in object-oriented programming series, as well as other computer or ICT videos by clicking or tapping on Emily Swap ICT YouTube channel below this video. Remember to subscribe to the channel by tapping on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email emilyswap@gmail.com. Thank you very much for listening to me. Let's meet in tutorial part 17 in the 95 part series, and God bless.